Picture this. You are a government policy advisor.
Right.
You just sat down at your desk with your morning coffee, and you are staring down an absolute mountain of proposals for new public service initiatives.
Oh, I know that feeling.
Yeah, your inbox is totally overflowing. Everyone in your department, from the, summer interns all the way up to the director general, is completely obsessed with AI.
Naturally.
But the proposals actually sitting on your desk, they are just a chaotic, overlapping mess. You've got pitches for citizen-facing chatbots, internal data scrapers, automated workflow tools, predictive analytics dashboards.
It's just a buzzword soup at that point.
Exactly.
Yeah.
So how do you actually prioritize any of this? And maybe more importantly, how do you avoid wasting millions in taxpayer money on flashy technology that sounds incredible during a slick vendor pitch, but, fails to solve a single real problem for your citizens or your staff?
It is an incredibly overwhelming position to be in, and it's happening in almost every public sector office right now. I mean, the pressure to modernize is immense. It's coming from both the public and political leadership.
Right. Everyone wants to be the AI mayor or the AI director.
Precisely. But the strategic roadmap is almost entirely missing. You are essentially being asked to rebuild the airplane while you are currently flying at 30,000 feet. And every single vendor knocking on your door is trying to sell you a completely different type of engine, promising it will, magically fix everything.
Which is exactly why we are dedicating this entire deep dive to you, the policy advisor. We are pulling our insights today from a really compelling source. It's the AI Integration Matrix Framework.
Yeah, this is a great one.
Right. It's an August 2025 strategic white paper published by the Dubai Digital Authority, or the DDA. And I want to set the table right away. This isn't just an academic thought experiment or a theoretical think piece.
No, not at all.
This is a battle-tested reference model. The DDA is currently using this exact framework to govern and deploy over 100 different AI systems across their government infrastructure.
And that operational reality is what makes this document really worth dissecting. The objective of this deep dive is to give you a structured methodology, basically a shared objective language.
Like a way to actually evaluate these things.
Exactly. We want to equip you to balance those critical internal operational upgrades with the highly visible citizen-facing services. We're going to break down how to classify, evaluate, and actually scale AI responsibly.
Because you can't just buy random apps.
Right, because the underlying thesis of this source is that AI must be deployed with structural coherence. It cannot be just a patchwork of disconnected apps and pilots slapped onto legacy government problems.
So let's start with the core problem the DDA identifies. Governments right now are being squeezed in a vice.
They really are.
On one side, you have this massive rise in public expectations. Citizens want government services to be as fast and seamless as, ordering something online.
Yeah, the Amazon effect.
Exactly. But on the other side, you have intense pressure to reduce operating costs and cut budgets. And that combination almost always leads to panicked, directionless AI adoption. So to solve this, the DDA organizes AI into a two-dimensional grid.
Let's examine the mechanics of those dimensions. The first dimension is the deployment scope. Think of this as the who.
Okay, the who.
Right. On the vertical axis of our matrix, we distinguish between internal systems and external systems. Internal systems are your back office operations. They support government staff, they manage data, handle human resources, process internal workflows.
Stuff the public never sees.
Exactly. And then external systems directly serve the citizens, businesses, and outside stakeholders who are interacting with the government.
Okay, so the inside of the house versus the outside of the house.
That's a perfect way to look at it.
Mm-hmm.
Then the second dimension is the technological approach. This is the how, and it sits on the horizontal axis. Here, the framework divides AI into two very distinct categories: autonomous agents and retrieval augmented generation.
Which people usually just call RGRU systems.
Right, RG. So autonomous agents are systems engineered to execute tasks. They can operate independently based on rules, logic loops, and machine learning. They take actual actions to change a state or complete a workflow.
They do stuff.
They do stuff. READ systems, conversely, are designed to deliver highly contextual information. They retrieve data from your existing knowledge bases and synthesize it into insights.
I understand the definitions, but why these specific dimensions? I mean, if I'm a policy advisor, a 2x2 grid feels almost too simple. Why did the DDA choose this exact way to slice up incredibly complex neural networks and machine learning models?
Because those dimensions represent the fundamental strategic divide in public sector priorities. If you forget the underlying code for a second and just look at the functionality,
Right.
Autonomous agents are about doing things faster. They are task executors. RG systems are about knowing things better. They are knowledge synthesizers.
Okay, doing versus knowing.
Exactly. Combine that with the who. Internal for government efficiency, external for public service. By mapping these two dimensions against each other, you capture the entire functional ecosystem of what a government entity actually does on any given day.
Let's ground this a bit more. I want to build out an analogy. Let's imagine your government department is a massive, high-end restaurant.
A restaurant. All right, I like it. Let's see how the mechanics map to that.
So if we look at the how, the technological approach, RG systems, the ones that retrieve information and synthesize it, that's your incredibly knowledgeable waitstaff and your sommelier.
Oh, that's a good comparison.
Right, because they have memorized the recipe book, the wine list, all the allergy constraints. You ask them a question, they retrieve the information, and they synthesize a perfect recommendation. But they aren't actually making the food.
Right, they are just retrieving and presenting.
Exactly. And the autonomous agents, those are the line cooks in the kitchen, they're actually grabbing the ingredients, chopping the vegetables, grilling the steaks, and plating the dish. They're executing tasks.
That actually maps incredibly well to the technical reality. A RAI system is essentially a sophisticated search engine paired with a language model. It is constrained by the text it retrieves. It reads the menu and tells you about it.
It doesn't invent new recipes.
Right. An autonomous agent operates differently. It is given a set of instructions, access to tools or APIs, and the autonomy to execute a sequence of actions to achieve a goal. It cooks the meal.
And just to finish mapping the grid, the internal dimension is your kitchen staff, your inventory management, your payroll. It's the people keeping the business running behind closed doors.
Right.
And the external dimension is your dining room, where the paying customers actually sit, read the menu, and experience the service.
And if we push your restaurant metaphor further, it perfectly illustrates the central warning of the DDA framework.
Which is what?
Well, imagine if a restaurant owner only invests their budget in hiring charismatic waitstaff and buying beautiful dining room decor, the external informational side. But their kitchen is completely neglected. They're using dull knives, broken stoves, and paper tickets that keep getting lost.
The entire operation will collapse.
Exactly. The waitstaff will take 100 orders perfectly, but the kitchen won't be able to deliver a single meal.
Wait, let me push back on this premise just a little. If I'm a policy advisor and I have a set budget I need to allocate before the end of the fiscal year,
Sure.
why do I actually need to map things on this grid? I mean, if a vendor comes to me with an incredibly well-reviewed AI tool that happens to be an external chatbot, why can't I just buy the best tools on the market as they come along? Why do I need to worry about the overall balance of the matrix?
Because optimizing for isolated, quote-unquote, best-in-class tools without a structural roadmap is exactly how governments create operational bottlenecks.
How so?
It is incredibly tempting to buy that highly visible external chatbot. It looks fantastic in a press release. The mayor can point to it and say, look, we are an AI-driven city.
Right, it's good PR.
But if that chatbot makes it 10 times easier for citizens to submit complex zoning applications, and your internal staff are still manually reviewing those applications using 30-year-old legacy software, you haven't solved a problem.
Oh, wow, yeah.
You have just weaponized demand against your own workforce. The matrix forces you to visualize the whole board. You cannot scale external engagement without simultaneously scaling internal capacity.
You cannot build demand without building supply. That is a brutal reality check, honestly.
It really is.
So let's actually unpack the 4 strategic quadrants this matrix creates. Let's see what happens when these dimensions cross. We will start with quadrant 1.
Quadrant 1 sits at the intersection of internal and autonomous agents. These are your back office engines. These are systems that automate internal government operations, manage internal processes, and execute administrative workflows. They operate entirely out of the public eye.
The line cooks, the ones actually doing the heavy lifting in the back.
Yes, exactly. The DDA white paper highlights several specific deployments here. One primary example is a document routing agent.
Okay, walk me through that.
In a typical government office, an astonishing amount of human capital is wasted simply figuring out where a digital form or a piece of physical mail needs to go.
Oh, I believe it. The mailroom shuffle.
Right. An intelligent routing agent uses natural language processing to read incoming documents, classify the intent, cross-reference it with departmental responsibilities, and automatically direct it to the correct queue without human intervention.
But let's talk about the actual mechanics of that, because government documents are famously messy.
They are terrible.
Right. So what happens when a citizen submits a handwritten, poorly scanned, vaguely worded complaint about a pothole that also, I don't know, mentions a broken street lamp. Does the agent just guess where it goes?
That is where the architecture of an AI agent differs from basic traditional automation. A traditional rules-based automation script would fail instantly on that document because it doesn't fit a predefined template.
It would just throw an error.
Exactly. But an AI agent uses optical character recognition to digitize the text, and then a large language model analyzes the semantic meaning. If the confidence threshold regarding where to send it is below, say, 90%, the agent doesn't guess.
Whoa.
It flags it for a human-in-the-loop review. But for the 80 or 90% of documents that are straightforward, the bottleneck completely disappears.
That makes sense.
Another example they provide is a meeting scheduler agent that coordinates availability across multiple, secure, totally siloed department calendars.
Which brings up a massive political friction point.
So the unions.
Yes. If I am sitting in a room with the public sector labor union and I pitch Quadrant 1, document routing agents and scheduling agents, their immediate reaction is going to be, you are using taxpayer money to automate away administrative jobs. You are building systems to fire our staff.
Yes.
How does a policy advisor navigate that conversation?
It is easily the most common piece of resistance, and the framework provides a very clear philosophical stance to counter it. The objective of Quadrant 1 is not headcount reduction. It is capacity expansion and burden alleviation.
Can you explain the difference?
Governments are facing a massive demographic cliff. Senior staff are retiring rapidly, and hiring freezes are common everywhere. The volume of work is increasing while the workforce is shrinking.
Right, doing more with less.
Exactly. If a mid-level employee is spending 3 hours a day manually sorting intake forms and playing calendar Tetris via email, that is 3 hours in saying they're not spending analyzing policy outcomes or providing direct, empathetic support to complex citizen cases that an AI cannot handle. Quadrant 1 removes the robotic work from the human.
Okay, freeing humans to do actual human work. I like that framing. Let's move to Quadrant 2. This is the intersection of internal and RREG systems, the knowledge partners.
This quadrant focuses on internal search, retrieval, and synthesis. These systems utilize vector databases to ingest vast amounts of internal government data. So, policy manuals, historical budgets, legal codes.
Basically all the boring PDFs.
Yes, millions of them. And they allow staff to query that data using natural language, receiving highly contextual, cited answers back.
The examples in the source are actually fascinating. They mention a training and development portal, a technical documentation assistant, a budget and financial guidance system.
All incredibly useful.
When you think about the mechanics of this, giving an employee access to a highly tuned Quadrant 2 system is essentially like assigning every single junior government employee their own veteran mentor.
That is a great way to put it.
Right, a mentor who has memorized every policy ever written, sits at their desk and just whispers the exact right regulation in their ear whenever they ask.
It's vital because institutional knowledge decay is a massive vulnerability in the public sector.
What do you mean by knowledge decay?
Well, when a 30-year veteran of the Municipal Planning Office retires, their highly specific, nuanced knowledge usually leaves the building with them.
Right, all the unwritten rules.
Exactly. A new policy advisor might take 6 months just to understand the intricacies of historical budget allocations. A Quadrant 2 RG system mitigates that decay.
That's so...
A junior staffer can just ask the system, what were the historical budget allocations for public parks in the North District over the last 5 years, and what specific municipal codes govern their maintenance contracts?
And instead of spending 3 days digging through shared drives and dusty PDF archives, the RG system pulls the exact paragraphs from 5 different documents and writes a coherent summary.
Exactly. And crucially, it cites its sources. The staffer can click the link and verify the original document. It dramatically accelerates the competence of the entire workforce.
But I imagine the trap here is the quality of the data.
Always.
If your historical documents are a mess of contradictory policies and outdated rules, your super mentor is going to confidently give you terrible advice.
That is the absolute Achilles heel of Quadrant 2, which we will address deeply when we look at the DDA's governance model later. You cannot build a clean RG system on top of a toxic data swamp.
Right. Garbage in, garbage out. So let's pivot outward to Quadrant 3, the interception of external and autonomous agents, the citizen service executors.
Now we enter the high-stakes, public-facing domain. These systems directly interact with citizens to deliver actual services.
So not just answering questions.
No, they are processing applications, issuing permits, and guiding users through complex transactions autonomously.
The white paper highlights a public meeting navigator. Let's look at how this works in practice, because right now, if a citizen wants to participate in a local zoning meeting about a new development in their neighborhood, it's awful.
It really is.
They have to navigate a labyrinthine, outdated municipal website, find a PDF of an agenda, figure out the date, and then show up physically. It is an exercise in total frustration.
Some people just give up.
Exactly. But a Quadrant 3 agent changes that entirely. The citizen just tells the agent, I care about the new development on 5th Street.
And then the agent takes over.
Right. The agent finds the relevant hearings, registers the citizen, puts it on their personal calendar, and sends them the briefing packet. It executes the task on their behalf.
Which is incredibly empowering for the citizen. But the stakes for failure in Quadrant 3 are astronomically high.
Why higher than the internal ones?
If a Quadrant 1 internal routing agent sends a document to the wrong department, an employee notices, flags it, and fixes it. It's a minor annoyance.
Okay.
But if a Quadrant 3 external agent incorrectly rejects a citizen's business license application, or worse, mishandles their personal financial data, you have an immediate public relations crisis, a loss of trust, and potentially a massive lawsuit.
Wow, yeah. Which is exactly why you don't start your AI journey by building a Quadrant 3 system.
Precisely. Which brings us to the final box, Quadrant 4, external RAG systems, the public informants.
This is the intersection of external and ARIG. These are the systems providing instant, reliable answers to the public based on government data.
So instead of a citizen digging through FAQs and complex legal jargon on a website to understand how to apply for a small business grant, they simply ask a natural language question.
And it answers them like a human would.
Right. The RKey system pulls the answer directly from the published government guidelines and translates it into plain, accessible language.
This is the classic customer service chatbot.
It is.
And frankly, this is where almost every government agency starts. They buy a Quadrant 4 tool because it is highly visible, it feels like an easy win, and the vendors are just pushing it relentlessly.
And that instinct is exactly what the Matrix is designed to correct. If we look at the holistic picture, you can see how dangerous it is to deploy Quadrant 4 without the other three.
Walk me through the danger there.
Let's trace the domino effect. You launch a brilliant, seamless Quadrant 4 system that perfectly answers every citizen's question about how to apply for a highly desirable municipal grant. What happens next?
Well, you completely remove the friction of understanding the grant process, so naturally you get a massive, unprecedented spike in actual grant applications.
Yes, and if you haven't built the Quadrant 1 internal agents to automate the intake and routing of those thousands of new applications,
Oh, I see where this is going.
and you haven't built the Quadrant 2 internal RA systems to help your overwhelmed staff quickly verify compliance rules for those specific grants.
You have engineered a systemic failure.
Exactly.
Right.
You generated massive public demand that your back-office infrastructure cannot physically meet. The citizens are happy with the chatbot, but they're going to be furious when their application takes 6 months to process.
You built the beautiful dining room, you hired the perfect sommelier, but you didn't buy any stoves for the kitchen.
That's right.
The customers are sitting at the table starving.
The DDA framework insists that supply must be built alongside or even ahead of demand. And there is a fascinating forward-looking element in the white paper regarding how these systems will eventually interact.
Oh yeah, the A2A stuff.
Right. Currently, we view these quadrants as distinct. A chatbot talks to a citizen in Q4, a routing agent moves a file in Q1. But the roadmap points toward agent-to-agent, or A2A communication.
Okay, I read that part and it honestly felt like science fiction. What does A2A actually mean for a government workflow?
It means breaking down the silos between the quadrants entirely. It means that an external agent in Quadrant 3, which is taking a complex permit request from a citizen, hits a roadblock.
Okay.
Instead of pausing and routing the request to a human queue, it autonomously pings an internal RG system in Quadrant 2 to query the policy constraints.
Wait, really?
Yes, and then it directly communicates with an internal agent in Quadrant 1 to initiate the background checks. Data and execution flow seamlessly across the matrix without human data entry ever acting as a bottleneck.
That is incredible, but also kind of terrifying from an oversight perspective.
It definitely raises questions.
But before we get to the future of autonomous government, our listener has to deal with the messy reality of their current desk. This leads us to the critical first phase of the DDA's implementation methodology, assessment and planning. How do you actually find the blind spots in what you are already doing?
The very first actionable step for a policy advisor is an exercise in radical transparency. You have to gather up every single AI proposal on your desk and every pilot project currently running in the shadows of your various departments, and you map them physically onto this four-quadrant grid.
I love the tactical nature of this. You literally draw a giant 2x2 grid on a whiteboard, take a stack of sticky notes representing your projects, and stick them in the boxes.
It is a revealing exercise because it instantly visualizes your organizational imbalances.
I want to walk through a hypothetical scenario. Let's say you, the policy advisor, do this whiteboard exercise with your IT director. You look at the board and you see 15 sticky notes crowded into quadrant 4. You have custom chatbots for the parks department, a chatbot for parking tickets, a chatbot for library hours. It's a crowded mess.
Very common.
But then you look at quadrant 1, internal agents, and the box is completely empty. Your staff are still manually entering data from paper forms into a mainframe from 1998.
That visual imbalance stops siloed, departmental thinking immediately. The IT director can no longer argue that they are running a successful modernization program because the matrix proves they are building a fragile facade on a crumbling operational foundation.
It's undeniable when you see it laid out like that.
It forces a strategic reset.
But there is a massive caveat in the source regarding this assessment phase. When you are assessing an organization's readiness to actually fix these imbalances and deploy AI, the logical instinct is to look at your technical infrastructure. Like, do we have the cloud storage?
Right, or do we have the computing power?
Exactly. Or to look at staff capability. Do we have data scientists? But the DDA explicitly states that the absolute primary prerequisite for readiness is none of those. The primary prerequisite is leadership drive.
The source is uncompromising on this point.
Why is that?
Because the realities of public sector transformation are deeply political and highly resistant to change. If an IT director tries to push a Quadrant 1 automation project from the bottom up, they will run into a brick wall of departmental territorialism, budget constraints, and risk-averse middle management.
You mean the classic, we've always done it this way, why change?
Exactly. Without explicit top-down leadership conviction, meaning the mayor, the director general, the cabinet minister, there is no budget authorization.
Right.
There is no air cover to absorb the inevitable friction of changing workflows. And most importantly, there is no public trust. If leaders are not championing the vision and explaining why the government is adopting AI, the public will view it with deep suspicion.
They'll just think you're replacing humans with robots to save money.
Exactly. The infrastructure and the engineering talent are secondary problems. They can be bought or built. Leadership conviction cannot be outsourced.
Okay, so assuming you have the leadership on board and you have mapped your gaps on the whiteboard, you know you need to build some internal capacity. But you still have 50 proposals and budget for 5.
A classic bottleneck.
How do you decide what actually gets built first? This is where the DDA introduces their prioritization engine.
This is perhaps the most pragmatic tool in the entire framework. It is a prioritization model designed to evaluate project complexity and strategic risk across the quadrants.
And it uses math, right?
Yes. It takes the emotion and the vendor hype out of the decision-making process by using a weighted mathematical formula.
Now, I have to admit, when I'm reading a strategic policy white paper and I suddenly encounter an algebraic formula, my eyes usually glaze over.
I think that's most people's reaction.
But when I actually looked at the mechanics of this, I realized it is an absolute superpower for a policy advisor. Let's break down the 5 criteria and their specific weights.
The model uses 5 weighted criteria to generate an objective score from 1 to 5 for every proposal. The first and most heavily weighted criterion is impact potential at 30%.
Okay, 30%.
This evaluates the tangible benefit to the citizen, the projected operational efficiency gains, and the hard cost reductions.
Makes sense. Second is implementation feasibility, weighted at 25%. This is the reality check. It looks at technical complexity, the current state of your data, the resources required, and the timeline. Essentially, do we actually have the capacity to build this, or is it a pipe dream?
Third is strategic alignment at 20%. Does this specific tool fit the broader digital strategy of the government, or is it a rogue pet project for one specific manager?
We all know those managers. Fourth is resource availability at 15%. Do we have the physical budget, the staff bandwidth, and the vendor support available right this second to execute?
And finally, the 5th criterion is risk assessment, which is weighted at 10%. This evaluates the security implications, the privacy concerns regarding citizen data, and the potential blast radius if the system completely fails.
Okay, let's test this engine. I want to pitch you a terrible hypothetical proposal, and I want to see how the math filters it out.
Right, hit me.
I am a vendor, and I am pitching you a Quadrant 4 external ARAG system. It is an AI that analyzes a citizen's tax return and generates a custom, personalized, rhyming poem explaining their tax bracket to them via text message.
Oh, wow.
It uses cutting-edge generative AI. It's incredibly flashy. Everyone is going to love it.
All right, let's run it through the engine. Impacts potential.
Yeah.
Does it reduce costs or meaningfully improve a vital citizen service? No, it's a gimmick. Score 1.
Fair enough.
Implementation feasibility. Generating millions of custom poems via SMS securely. High technical complexity for very low reward. Score 2. Strategic alignment. Unless your government's stated goal is literary entertainment, it doesn't align. Score 1. Resource availability. We'd need massive cloud compute to run the generation. Score 2.
And the risk.
Risk assessment. You are feeding highly sensitive taxpayer financial data into an LLM just to generate a poem. The privacy risk is astronomical. So that's a score of 5 for high risk, which in this model actually translates to a low prioritization score of 1.
So you multiply all those low scores by their weights, impact times 0.3, feasibility times 0.25, and so on, and you end up with an overall score hovering around a 1.2 out of 5. The project is dead on arrival.
Precisely. It provides a mathematical shield. When a persistent vendor, or even an enthusiastic department head, pushes a flashy but useless tool, you don't have to argue opinions.
You don't have to be the bad guy.
Right. You run the numbers and say, the impact score and feasibility metrics result in an overall score of 1.2. The threshold for Phase 1 funding is 4.0. We cannot proceed. It enforces discipline.
I see the value, but I have a major bone to pick with the weights themselves.
Oh.
Impact is heavily weighted at 30%. But risk assessment is weighted at only 10%. It is the lowest priority in the entire formula.
That surprises people.
In my experience, government culture is defined by risk aversion. Avoiding public failure is usually the #1 priority. Why on earth is risk weighted so low in this matrix?
That is a very perceptive challenge, and it touches on the core philosophy of the DDA. The framework fundamentally argues that you cannot innovate if you are paralyzed by risk.
Okay.
If risk assessment carries a 30 or 40% weight, you will mathematically never adopt any new technology because all transformative technology carries inherent risk.
So they are just ignoring the risk.
Not at all. The philosophy is about proactive management versus avoidance. You don't avoid the project because of risk. You fund the project based on its high impact, and then you heavily engineer security, privacy protocols, and failure mitigations into the deployment. You optimize for citizen benefit, and you manage the risk in the architecture. Weighting impact over risk is a deliberate mechanism to force a risk-averse culture to actually take steps forward.
That makes a lot of sense, actually. You can't let the fear of a data leak prevent you from upgrading a system that is currently failing thousands of citizens daily. And the framework also notes that the context of the evaluation changes depending on the quadrant.
Context is critical here. If you are evaluating an external agent in Quadrant 3, your risk assessment must heavily scrutinize accessibility, public acceptance, and bias, because you are dealing directly with diverse populations.
Right.
But if you are prioritizing an internal RG system in Quadrant 2, your risk focus shifts entirely to internal data governance, access controls, and knowledge accuracy. The math remains the same, but the qualitative questions adapt to the quadrant.
Once you run your entire whiteboard of sticky notes through this formula, the framework dictates a roadmap phasing guide. You segment everything by score. Phase 1 is your quick wins. These are projects that score a 4.0 or higher. They have high impact and high feasibility. The timeline for these is 1 to 6 months.
Phase 2 is designated for strategic implementations, spanning months 7 through 18. These are your solid, medium to high impact projects, scoring around 3.5 and up. They are valuable, but they might involve moderate technical complexity or require you to integrate data across different silos.
And Phase 3 is advanced capabilities for months 19 to 36. These are the highly complex, massively transformative implementations that will take years of foundational work before they can launch safely.
Staging the deployment this way is a survival tactic for AI programs.
Why survival?
The white paper stresses that if you only focus on a massive Phase 3 project, you will spend 2 years spending money without showing any results. Stakeholders will lose patience, and leadership will cut the funding.
Oh, absolutely. They want to see what they paid for.
Right. Demonstrating early, undeniable momentum with Phase 1 quick wins is what secures the ongoing political capital. and builds the staff confidence required to survive those long, difficult Phase 3 projects.
Securing a quick win is great for morale, but how does a massive bureaucratic organization actually scale these capabilities over time? This leads us to the maturity model journey.
The DDA provides a 5-level maturity model. It is a diagnostic tool to help organizations understand exactly where they are in their evolution and what they need to do to reach the next stage of scale.
Let's walk through the levels.
Level 1 is initial awareness. This is the messy baseline where most organizations currently reside. It's characterized by ad hoc, reactive, and completely isolated pilots.
So like the Parks Department bought a subscription to an AI writing tool.
Exactly. And IT is testing a server script, but nothing is connected.
I want to ask the listener to do another mental check right now. If you look at your department right now, are you stuck at level 1? Are there just random, uncoordinated pockets of AI usage popping up like weeds, driven by individual managers rather than a central strategy?
If the answer is yes, the immediate goal is to progress to level 2, which is planned development. At level 2, you establish a coordinated strategy. You introduce basic governance structures like the prioritization engine we just discussed.
You stop reacting and start planning.
You start using the matrix to intentionally plan deployments rather than just reacting to vendors.
And then comes level 3, systematic implementation. The framework describes this as the major inflection point. At level 3, you have achieved comprehensive, governed AI coverage across all 4 quadrants.
The leap from level 2 to level 3 is rarely a technical hurdle. It is a psychological and cultural hurdle. It represents this shift from an organization saying, we are experimenting with this new AI tool, to an organization realizing this is fundamentally how our government operates now. AI ceases to be a shiny novelty and becomes invisible core infrastructure, much like electricity or the internet.
But getting humans to accept that shift requires massive friction. I mean, people hate changing their workflows.
Which is why the white paper heavily emphasizes change management. Scaling AI is as much about human psychology as it is about neural networks.
Give me an example of that failure.
Well, if you deploy a brilliant Quadrant 1 routing agent, but you don't aggressively train the staff on how to monitor it, and you don't clearly communicate how it benefits them personally, they will actively bypass it and return to their manual processes out of pure habit.
Yeah, they'll just go back to the paper forms.
Exactly. Without continuous stakeholder engagement, you will never sustain level 3.
Assuming you survive that cultural shift, you move to level 4, optimized operations, where the systems are continuously refining themselves based on advanced analytics. But I want to spend some real time on the final destination. Level 5, predictive and proactive. What does a level 5 government actually look like in practice?
A level 5 organization represents a paradigm shift in the very nature of public service. Historically, governments are reactive entities. A citizen submits a complaint, the government processes it, and eventually resolves it.
Right.
At level 5, the matrix operates predictively to eliminate the need for the complaint entirely.
Walk me through a concrete scenario of that.
Let's look at municipal infrastructure. In a reactive model, a water main bursts, a street floods, citizens call the emergency line, and a crew is dispatched.
A mess.
In a level 5 predictive model, an internal agent in Quadrant 1 is continuously analyzing real-time data streams. So, water pressure sensors in the pipes, historical maintenance records, and upcoming weather forecasts showing a massive freeze.
Oh, well.
The agent detects an anomaly, indicating a high probability of a pipe failure in the next 48 hours. Autonomously, it generates a predictive work order and routes it to a maintenance crew.
So no human has to spot the anomaly.
Right. And simultaneously, it triggers an external RAGI system in Quadrant 4 to push a proactive notification to the specific neighborhood portal, advising residents of planned preventative maintenance.
So the crew arrives, replaces the stressed valve, and the pipe never bursts. The street never floods. Nobody's basement is ruined.
Exactly. The citizen experience is seamless because the crisis was averted before it materialized. That is the ultimate return on investment of balancing the 4 quadrants.
It sounds utopian, honestly, but the DDA is actually building toward this. Let's look at the concrete evidence in our final section, lessons from the Dubai Digital Authority case study.
The DDA did not write this white paper in a vacuum. They developed a specific matrix in early 2024 to wrangle their own massive, sprawling deployment of over 100 distinct AI systems.
100 systems is huge.
And they are surprisingly candid in the document about their early failures. Before they instituted the matrix, there was organizational confusion. Executive management lacked a clear, unified direction, and the technical engineers were simply building things haphazardly because the technology was new and exciting.
They were completely caught in the hype cycle, basically building solutions in search of problems.
Precisely. The introduction of the matrix brought immediate clarity. It forced executive management to define a specific, measurable purpose for every single AI system, ensuring that each project actively contributed to a broader strategic goal rather than just existing as a technical novelty.
The scale of what they are doing is really impressive. The case study notes they are planning 40 external agents and 12 external RG systems. But what I found most validating was looking at their absolute highest priority projects.
Yes, the 4.5.
Right. When they ran their own proposed systems through that mathematical prioritization engine we just talked about, the ones that scored a 4.5 or higher, the absolute top tier, were a document processing agent for Q1, a budget anomaly detector for Q2, a citizen service information portal for Q3, and a policy knowledge base for Q4.
Notice the distribution there. Their highest priorities hit every single quadrant. They didn't just approve 40 external chatbots and call it a successful AI strategy. They're enforcing balanced development across the entire operational ecosystem.
But having a brilliant framework on paper is useless if the human teams building it are dysfunctional. The DDA case study provides a very specific guide for aligning team roles, which I think is crucial for our listener to understand. How do you govern this beast?
They utilize a highly structured, dual-layered governance model.
Hmm.
At the apex, you have the program office. This body is responsible for the overarching strategy, budget allocation, and top-down direction. They hold the vision,
Okay, the executives.
but beneath them, dedicated to the specific execution of the matrix, are the quadrant working groups.
And who actually sits in those working groups? Because if it's just a bunch of software engineers in a basement, the tools are going to fail when they hit reality.
That is the genius of their alignment strategy. The working groups are rigorously cross-functional. If you look at the Quadrant 1 working group, you have the technical engineers and data scientists, yes.
Right.
But sitting at the exact same table are policy advisors, service designers, and critically, the frontline administrative staff who actually do the manual work every single day.
That is the secret sauce. By putting the frontline staff, the people who actually feel the daily friction, who know exactly why a certain form always gets filled out incorrectly, by putting them in the same room as the engineers building the automation, you ensure the AI is solving the actual problem, not the theoretical problem.
It creates a vital two-way exchange of information. The strategic mandates flow down from the program office, but the practical, gritty realities of execution flow back up from the working groups. And to prevent chaos, the DDA enforces a strict initiative approval process. It acts as a hard gatekeeping mechanism. No project, regardless of how enthusiastic a department head is, receives a single dollar of funding or an hour of engineering time until it passes a rigorous business case validation mapped against the matrix.
I'm going to highlight one highly specific point from the technical architecture section of the case study before we finish. The source talks extensively about ethics, privacy, and security being essential pillars of deployment. Obviously, those are table stakes.
Correct.
But the authors explicitly single out data governance, calling it the true game changer. They position it as the most critical element of the entire endeavor. Why? Why is data governance the absolute hero of this story, above even the AI models themselves?
Because an AI system, whether it's a RAG or an agent, is fundamentally only as intelligent and as useful as the data it is fed.
Right.
Let's say you spend millions building a highly advanced, flawlessly coded autonomous agent to route financial documents in Quadrant 1. But your underlying financial data is stored across 5 different legacy systems, it is formatted inconsistently, and half of it is outdated. That cutting-edge agent is simply going to execute the wrong financial tasks at lightning speed.
It will automate your dysfunction.
Exactly. Clean, structured, heavily governed data is the invisible foundation upon which all 4 quadrants rest. Without it, the entire matrix collapses into chaos.
It goes back to our restaurant kitchen. You can hire a world-class Michelin star chef. You can give them the sharpest knives and the best stoves. But if you hand them completely rotten meat and moldy vegetables, it does not matter how brilliant their technique is, the meal they produce is going to be toxic.
A perfect analogy. And the DDA institutionalizes this data hygiene through what they call shared infrastructure components, located in Layer 2 of their technical architecture.
What does that mean, practically?
They mandate that things like central user authentication, unified monitoring dashboards, and strict data governance protocols must span universally across all 4 quadrants.
So the Parks Department chatbot uses the exact same data rules as the Finance Department routing agent.
Exactly. This shared infrastructure is the connective tissue. It is what prevents the four quadrants from devolving into isolated, incompatible silos, ensuring they operate as one cohesive, secure ecosystem.
Okay, we have covered an immense amount of strategic ground today. Let's bring it all back home for you, the policy advisor sitting at your desk. You are no longer flying blind. You now have a highly structured, battle-tested tool, the four-quadrant AI integration matrix.
You're ready to tackle that inbox.
Right. You understand how to map your current messy pile of projects to a whiteboard to instantly spot your operational gaps and imbalances. You know how to utilize the 5-point prioritization engine to score aggressive vendor proposals objectively, prioritizing high citizen impact while proactively managing the technical risks.
You know how to structure your human teams.
Exactly. Establishing a strategic program office and cross-functional working groups to scale your organization through the maturity model from isolated pilots all the way to predictive, proactive governance.
You now possess a shared objective language to bring to your next chaotic department meeting. The next time the IT director or a vendor pitches a new AI tool, you don't have to rely on gut feeling. You can ask, is this an internal agent or an external RAG? Which of the four quadrants does it serve, and how does it balance against our current operational bottlenecks?
It takes the mountain of buzzwords on your desk and distills it into a clear, strategic, defensible roadmap. But before we wrap up, I want to leave you with one final, slightly provocative thought to mull over. Earlier, we explored the concept of agent-to-agent or A2A communication. The white paper firmly envisions a near future where these four quadrants are not just balanced, but seamlessly interacting with each other.
Yes, a state where systems trigger and reinforce one another entirely without human bottlenecks.
So imagine this scenario playing out a few years from now. An external agent in Quadrant 3 is communicating directly with a citizen, negotiating a highly complex request for a commercial building permit. During the negotiation, the agent encounters a constraint regarding municipal budget allocations for the required infrastructure.
A very common roadblock.
Right. But without pausing to alert a human manager, that external agent directly queries an internal RGV system in Quadrant 2 to analyze the historical policy precedent. Based on that context, it then negotiates directly with an internal agent in Quadrant 1, autonomously reallocating departmental resources and adjusting ledger entries to instantly approve the permit.
Wow.
The entire complex, multi-layered policy interaction happens end-to-end, machine-to-machine in milliseconds. If these four quadrants can eventually communicate, negotiate, and execute complex public policies entirely autonomously, at what point does this matrix stop being a structural tool for government employees and start becoming the functioning government itself? And when that day inevitably arrives, where exactly does the human policy advisor fit inside that matrix?
That is the ultimate existential question regarding public sector automation, and it is one we will all have to answer much sooner than we think.
Something to think about the next time you are staring at that stack of proposals on your desk. Thank you so much for joining us for this deep dive.